So hello everyone, we are back again now, this time with question number 6, and you can see today I have removed the other distraction as well. So we have only question 6 on the screen. I have removed everything else so that we can concentrate on question 6. So let's see what exactly is question 6 saying. It says figure 1.30 shows two forces each of magnitude 10 Newton. So we can see 10 Newton, two forces are available acting at point A and B at a separation of 50 centimeters. So you can see the separation shown is 50 centimeter, which is, if I'll ask you what is that in millimeter, in meter, that would be 50 upon 100, which is 5 by 10, which is 0.5 meter. That's our conversion. Please always remember that you have to get the answer in SI units. So centimeter, we have to convert it into meter. In the opposite direction, calculate the resultant moment of force, two forces about point A and B. So if I'll ask you what is the moment of force about A. So we can see if we observe A is at a distance of 0.5 meter from B, and from A, if we find out moment of force, it is 0. So total moment of force about A is, we can see 0 plus, it would be force into distance, which is 10 into 0.5. And because this is moving in, when we are talking about in the clockwise direction, both of them are in the clockwise direction. So this is clockwise. So our answer would be 5 Newton meter clockwise. Now, similarly, when we are talking about moment of force about B, there are two cases. B is at a distance of 0.5 meter from A, and from B, moment of force is 0 because the distance is 0. So it would be, we can say 0 plus, again, it would be 10 into 0.5. And this also is going in the clockwise direction. So answer is 5 Newton meter, and it is going in the clockwise direction. Now coming up to moment of force, it says O situated exactly at the middle of two forces. So when we are talking about at the middle of two forces, so from O to A, the moment of force comes out to be, the distance is half of 5.5, which is force is same, which is 10 into 0.25. So we get 2.5 Newton meter. That would be clockwise. Now this is when we are talking about O to A, the distance, the formula would be F into D. Now why we took D as 0.25 and not 5 is because we are talking about this distance, which is half. Now similarly, when we are talking about from O to B, similar answer we'll get is 0.2.5 Newton meter, which is again in the clockwise direction. So when we are talking about total moment of force about O, so total moment of force about O because of both the forces would be addition of both of them because they are in the same direction. So that would be 2.5 plus 2.5, which is 5 Newton meter clockwise direction. So this was question number 6. This usually seems to be easy, but there is little complication involved here. So this was question 5. I'm so sorry, question 6. We'll go to the question 7. If you have any doubt related to this question, put it in the comment box. In the meantime, we'll go to the question number 6. So you can see the screen is back here, and I'll just take you to question number 7 straight away. So the question number 7 goes like this. It says a steering wheel of diameter 0.5 meter. So this is the steering wheel. It has a diameter of 0.5 meter, is rotated anti-clockwise. So when we are talking about anti-clockwise, you can see it is rotated anti-clockwise, or we can draw like this also, right? So this is anti-clockwise direction. Anti-clockwise by applying two forces each of magnitude 5 Newton. So the forces are 5 Newton, 5 Newton. Draw a diagram to show the application of forces and calculate the moment of force applied. So when we are talking about moment of force applied here, we can see Here, because the two forces are acting in the opposite direction, so it is acting like a couple situation, and distance between them is same as diameter. So the formula would be moment of force, moment of couple, I can say, is equal to one of the force into distance between them. So this would be 5 into distance between them is 0.5. So answer comes out to be 2.5 Newton meter, and you can see it is moving in the anti-clockwise direction. So this was question number 7. We will be continuing with question number 8 onwards, because question number 8 onwards will start with the uniform meter rule. So if at all you're setting for question 8 in the next video, please sit with the ruler. It would be very interesting to learn. That's it from my end. Thank you and have a great time. Bye bye.